Hello. You see, today we will be discussing about a very important and useful chapter. Yeah, that is what we call vectors. Vector is a very important chapter for mathematics, and also it's a very important and a very useful chapter, for physics. Okay. Uh, what is a vector? Okay. We all know about the scalars because until now we have been discussing about the scalars. Let us say if I add 3 plus 5 3, if I add 3 and 5, then everyone say okay, the answer would be 8. So this is 3 plus 5 would be 8. Okay. uh, Now 3, what is 3? 3 maybe it is 3 meter plus 5 meter equal to 8 meter, or 3 kilogram plus 5 kilogram would be 8 kilogram. Okay. uh, these are all basically scalar quantities. Okay, these are all scalar quantities. Now what my intention in this lecture is to discuss on vectors. So vectors are little bit different. Okay, what are vectors? Vectors are those quantities which have the magnitude as well as direction. Okay, these have only magnitude. These have only magnitude. I mean, irrespective of the direction, if we add 3 and 5, the result would always be 8. But if it is a vector, then 3 plus 5 may not always be, will not always be 8. It could be 8, it could be 2, it could be minus 2, it could be anything between, minus 2 and 8. It will depend on the direction, in which direction is 3 or 5. Now, how can we have a direction of 3 and direction of 5? Because what is this 3? This 3, if it is a mass, then it cannot have direction. But if it's a velocity, then it will have a direction. If it's a displacement, if it's an acceleration, say if it's a force, then force has direction. Okay. And therefore, if say if I have an object here and I apply a force in this direction, say this is force is 5 Newton, and I apply an equal and opposite force that is also 5 Newton, then what would be the net force of the object? Net force would be 0. So 5 Newton and 5 Newton will not always make 10 Newton, maybe 0 Newton. 5 Newton and 5 Newton will be 10 Newton only in one case, when the 5 Newton is in this direction and another 5 Newton is also in the same direction. Then the total force on this object would be 10 Newton. Okay. That means what is the total resultant? What is the total effect? What is the total of the two? In this case the total is 10, whereas in this case the total is 0. Okay. That means it depends on the direction of the force, in which direction the force is being applied. Okay. And therefore many of the physical parameters depends on the magnitude as well as direction, and therefore we will be discussing about those parameters which are called as vectors. So basically vectors are those physical parameters which has magnitude and direction both. Okay. And therefore the handling of vector is slightly different than scalar. Not only slightly different, it is much more different. Okay. So we will be discussing about this thing, vectors. Okay. So as I said, the vectors has magnitudes. Okay. Vectors has magnitudes and direction. Has direction. Okay. Let's say if A is moving with 5 meter per second. A is moving with a velocity of 5 meter per second towards east, whereas B is also moving with 5 meter per second, but B is moving with the velocity of 5 meter per second, and B is going towards the north. So the the velocity of A and velocity of B will not be identical. will not be equal. Both has the same magnitude, but both velocities are different because they are in different directions. Okay. So therefore, a vector has magnitude and direction both. If we write only magnitude, then this is incomplete. If we want to express a vector completely, then we have to mention its magnitude and direction both. Okay. So I hope you know the importance of the vectors and what are vectors and how a vector is different from a scalar. Uh, Now, how the vector will be represented? A vector is represented by a straight line, a straight arrowhead. So this is the arrowhead. So this is basically a vector. Vector is represented like this. Geometrically, this is represented like this. And vector is shown by capital letters. Say this is a vector A. So this is represented by capital A, having an arrowhead on the head of this letter. So if there is a letter P having an arrowhead here on the top of its head, that means P is a vector quantity. Okay. So vector will normally be represented by the capital letters having an arrowhead on the top of the letter, and in geometrically this will be represented by this arrowhead. This length of the arrowhead will represent the magnitude of the vector. So this is the magnitude of this vector, whereas this arrow will represent the direction of the vector. So this is the direction of the vector. Okay. So this is a vector A whose magnitude is so much, okay, which is basically proportional to its length, and the direction is this. This is the direction of this vector. Say its velocity. Say the length of this is, let us say, 5 on some scale, okay, meter per second. That means this is a velocity. This vector is representing a velocity in this direction. Okay. Now if I make another vector, this whose length is again 5 meter per second, but this vector will not be A. This vector will not be vector A. This will be something else, because though the magnitudes are of both the vectors are equal, but the directions are different. So this vector and this vector will be different. Maybe we may represent it by some another name. This is vector B. Okay. So this is how geometrically a vector will be represented. Okay. Then mm, if I draw a vector which is half of its magnitude, okay, the direction is same. Okay. So if this vector was A, then this vector would be half A. This vector will be half times A. Okay. Or if I make a vector double its length, so if this is a vector whose length is double A, double then A, and direction is same, it is parallel to this, then this vector will be 2 times A. Okay. So if this vector is A, then this is 2 and this is half A. Okay. That means we can multiply the vector by some scalar number, 1, 2, half, minus 1, minus 2. Then its magnitude will get multiplied. Okay. But direction will remain same. If we multiply this by minus 1, that means this vector will become minus of A. That means multiplying by minus, that means we are changing the direction, opposite direction. So this vector would be minus A. Okay. So if this vector is A, then this vector would be minus of A. Okay. Another one more very important, very useful property of a vector we can move a vector from one place to another place. Okay, and vector will remain same as long as its magnitude is same and direction is same. That means it is parallel. That means if I take, if I make, a copy of this vector here, if I make a copy of this vector here, this vector, okay, so this vector will still be A. This vector is A, this vector will also be A, as long as their magnitudes are same and their direction is also same. So both the vectors will be A. So whether this vector I keep it here, I move this vector from here to here, or if I move this vector from here to maybe US or maybe Canada or maybe China, as long as their magnitude is same and their direction is same, this vector is A, this vector will also be A, the vector in US will also be A. So this is a very good property of the vectors. Vectors can be moved. Okay. So this is about the vectors. Okay. Okay. Now let us discuss about how to represent the direction of a vector. Okay. You see, in our normal course, in our day-to-day life, we can say that we are moving towards east direction or towards west, or towards north or south or something like that. But in mathematics, in physics, how we will represent this, these directions. So in mathematics or physics also, almost a similar pattern we will be using. Okay. Say for example, in our real life, we say that if this is east and this is west and this is north and say this is south, then we can say that this is a vector which is directed towards east, or this is a vector which is directed toward the north, or this is a vector which is directed towards west. Okay, or this is a vector which is directed towards south. Okay, or we can say that this is a vector which makes an angle of maybe 30° with east towards north, or maybe making an angle of 60° with north towards east. Okay, so we can represent a vector in any direction, vector whether the vector is here or vector is in this direction or vector is in this direction or vector is in this direction. Whatever is the direction we can represent. This is basically right now I am discussing on vectors in a plane, that is two-dimensional. We'll be discussing about the three-dimensional also, but right now we are discussing about the vectors in two dimension, vector in a plane. Okay. So many of the problems will be like this. The direction of the vector will be given with reference to a direction. So always remember, east will be always shown on the right side, west will be always shown on the left side, north on the upper direction, and south will be the downward side. Okay, so this will be the directions. Okay. In mathematics or also in physics, these four directions are a plane, can be and is represented by our coordinate planes. Okay, so we will have one x-axis, we have a y-axis, we have a negative x-axis and a negative y-axis. Okay, so this is as good as east, west, north and south. So sometimes we will be representing a vector like this towards x or towards y, are inclined with x and y and z. Okay, right. But then we will be giving some name to this x-axis and y-axis and x-axis, negative x and negative y-axis. Okay, but before that, before this, let us discuss what is a unit vector. Okay, what is a unit vector? A unit vector is a vector whose magnitude is unity, one magnitude. Okay. Say if as I told you, if this is a vector A, this was a vector A, okay, and say if its velocity is 1 meter per second, then it is a unit vector because magnitude is 1. Okay. Say if I have a vector here, this is 1 Newton force vector, say this is a vector F, then this is again a unit vector. Okay. So what is a unit vector? A unit vector is a vector whose magnitude is unity. Magnitude is 1. That is a unit vector. Okay. Then what is the use of unit vector? Okay. Let me first explain you how to denote a unit vector. A unit vector will be denoted by a cap on the letter. So if a cap, that means A is a unit vector. Here if we have F cap, that means F is a unit vector. Okay. If I write here P having a cap here, then P is a unit vector. That means this vector has a unit magnitude, one magnitude. Okay. Now let us come. What is the use of unit vector? Okay. What is the use of unit vector? Say if I write a vector in this direction. Okay. If I write a vector in this direction and I name it I. Okay. This is I. This is the direction and then this is I. Okay. That means I is a unit vector. That means its magnitude is 1. Okay. It could be anything. It could be displacement. It could be velocity. It could be force, anything. But magnitude is 1. Okay. So it's a unit vector I. Now, if I want to write 3I, if I want to write 3I, that means 3 times this. So I immediately write 3I like this. Okay. If I want to write 5I, I immediately write 5 times of this 5I. Okay. If I want to write minus I, so opposite of I will be minus I. And there is a cap always there. If I want to write minus 2I, so this is minus means opposite, minus 2I. Okay. So the moment I tell you vector is 5I, that means this direction 5 times I in this direction. So using using a unit vector, now my direction is fixed. Now I did not tell that this vector is in east direction or west direction. I should write only I. So I is a unit vector along x-axis. So unit vector along x-axis is I. Unit vector along y-axis is J. Unit vector along y-axis is J. Naturally, the unit vector along negative x-axis will be minus I, and negative, vector along negative y-axis would be minus J. Okay, so this is 3I. Okay, this is 2J, right? This is minus 4I. Okay, this is minus 3J. Okay, so instead of writing east, west, north, or south, we will be writing IJ. I means it is towards the positive side of x-axis, minus I means towards the negative side of x-axis, J means towards the positive side of y-axis, minus J means towards the negative side of y-axis. Okay. So, and of course, sometimes we will be using the word east, west, north, and south, and all those things. Okay. So, okay, now we start with vector addition. Vector addition. How do we add two vectors? Okay. How do we add? How do we add two vectors? Say vector is a let's say displacement vector. It's a displacement vector. Okay. Now here is a person who displaces in this direction by 3 meter. Okay. And then displaces again in the same direction by say the 5 meter. So now two vectors are acting on this. One is 3 meter, one is 5 meter. One is 3 meter, one is 5 meter. So if I add both this, then what will be the total displacement? The total displacement would be 8 meter. Okay. So I have added these two vectors. This was vector A, this was vector B, vector A plus vector B, vector A plus vector B. What was vector A? Say vector A was 3i and vector B was 5i. So total is 8i. A was along positive x-axis, B was along positive axis, therefore A plus B, 3i plus 5i, 8i. So this is the final vector. Okay. So that is the meaning of addition. Addition means the combined effect of both the vectors A and B, which we have to add the combined effect of both the vectors, which we have to add. That is the meaning of the word addition. In this case, both the vectors were in the same direction. But if the vectors were, let's say, in the opposite direction, so this was A, and B was in this direction. Say this was B. A was 3i and B was minus 5 of I. Then what will be A plus B? What will be A plus B? A is 3i and B is minus 5i. So resultant will be minus 2i. So final effect will be this minus 2i. If a person moves in this direction 3 meter and then moves in this direction by 5 meter, then the finally person from original position, he is at minus 2 meter from the original position. So the result is minus 2i. Okay. So we have added these two vectors. Okay. In both these examples where vectors were parallel or anti-parallel, we can say these. In this case the vectors were parallel in the same direction, here they were anti-parallel in the opposite direction. But vectors could be in any direction, say 3 meter in this direction and 5 meter in this direction, or 3 meter in this direction and 5 meter in this direction, or 3 meter in this direction and 5 meter in this direction. Okay, or 3 meter in this direction and 5 meter in this direction. So this is A and this is B, this is A and this is B, this is A and this is B, this is A and this is B. So what will be the resultant? What will be the resultant? The final displacement in this case is this. 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 Okay. If these two vectors are acting at a time, that means the person is reaching here, is starting from here and reaching here. If both the vectors are acting together, both the vectors are acting together, or say this is first vector is this and then we add this vector, then finally the destination is here, the initial point was here. So this is as good as the person has moved through along this line. So this is the result. This is the result of adding these two vectors. Okay. So a resultant vector will always be different. In this case, this is the resultant. The person has reached here. In this case, person has reached here. In this case, person has reached here. So the final result is different. Here also you have seen that the result is different. Here it was 8 meter and here this is minus 2 meter. 8i and minus 2i. Okay. So how do we handle such cases? Or let me explain you one more example. Okay. Say if mm, let's say if a person moves from here to here. Okay, so this is the displacement. Okay, this is the displacement. Say this is the displacement, and another displacement is, let's say, this. This is another displacement. So these are the two different vectors. This vector is, let us say, A, and this vector is, let's say, B. Then where is the person finally? The person finally started from A and then reached here. The person started from A and reached here. The person started from A and reached here. What will be the resultant of these two vectors? What will be the resultant if we want to, combine both this, and if we want to apply just one vector in place of these two vector, so that final result would be same. Okay, so what would be that vector? That vector is basically the resultant vector. That effect of that single vector and effect of these two individual vectors A and B would be exactly same. If we apply these two vectors A and B, or if we apply only that, that single vector, the result will be same. Outcome, final effect would be same. Then that single vector will be known as the resultant vector of A and B, and that we call A plus B. So that is the meaning of the word vector addition. So let us say A plus B equal to C. That means if we apply vector C only, or if we apply A and B both vectors on an object, then the effect outcome would be identically same. Say for example, if let's say this is, this is a trolley. Say this is a trolley, a big trolley, okay, and on this trolley, say this trolley, uh, say this vector A was, let's say, 5 meter per second, and vector B was, let us say, 7 meter per second. Okay, so this is a trolley. This is a big trolley. Okay, this trolley or a platform. This is a big platform, horizontal platform, and this platform is moving in this direction with a velocity of 5 meter per second. This is the vector. This platform is moving in this direction with a velocity of 5 meter per second, and a person is standing here. So this person will also move along with this platform with a velocity of 5 meter per second. The person, because the platform is moving, therefore the person standing on the platform would also be moving with the same velocity. Now, if we ask the person to start moving in this direction, if we ask person to start moving in this direction, okay, in which direction? We ask person, okay, you also start moving in this direction with a velocity of, say, 7 meter per second. So now two velocities are acting on that person. One is the velocity of the platform, because platform is moving. Therefore, person is also moving in the same direction with 5 meter per second. And now we have asked the person to move on the platform in that given direction, okay, with 7 meter per second. So the person is moving in this direction with platform, as well as the person is moving with 7 meter per second in this required direction. So two velocities are acting on the person. So after 1 second, where the person will reach? After 1 second, the person will reach to this place, which is 5 meter from here. 5 meter from here, the person would have reached this place, because the platform has moved 5 meter, as well as the person has moved 7 meter in this direction, as well as the person has moved 7 meter in this direction, because the person is moving in this direction. So where is the person finally? Person has reached here because of the movement of the platform, and person has reached here because of his own velocity. Okay, so now there are two displacement. One, this is the displacement of the platform, and this is the displacement of the person himself. Okay, so finally the person is here. His initial position was here and the person is here. Two vectors are acting on him. This is one vector which is the velocity of the platform, and this is another vector which is the velocity of the person himself. So if we call this as vector A and this as vector B, then this is the final resultant. This is the final resultant. And if we minutely observe every millisecond, every microsecond, if we minutely observe, then we will find that we will see that the person would have been moving. Person is basically moving on this path. Person is moving, on this path. If we observe the microsecond, if we observe after every millisecond, because the platform has moved this much distance, the person has moved this much distance. The platform has moved this much distance, the person has moved this much distance. Then platform has moved this much distance, person has moved this much distance. Then platform has moved this much distance, person has moved this much distance. Then platform has moved this much, person. So practically the person is moving along this path. If we look it from the top, if both are moving, the platform as well as person, you will find that the person is moving along this path, right? And this is the addition of these two vector A plus vector B. So this is the resultant of vector A and B, that is vector A plus vector B. We call this vector as the resultant vector, and we write it A plus B. If we say if this vector is R, this vector is A, and this vector is B, then we will say that vector A plus vector B is equal to vector R. R is the resultant of A and B. If we want to show both the vectors separately, then we have to show vector A and vector B like this. Or if we want to replace both these vectors by a single vector with the same identical effect, then we will have to write R. So R is equal to A plus B. R equal to A plus B. We have to understand this very clearly. Okay. R is the resultant of A and B. Okay. Now, how can we write the resultant of two vectors? That means if you want to write the resultant of two vectors, what you have to do is just make one vector A. Say this is A. Let me write once again. So say this is the vector A. Okay, I'm writing A plus B. Okay, I'm writing A plus B. So I first write A, then where the A terminates, where the A is terminating here. So here I start B and I write B here. So this is B. Okay, so this is B. First I draw A, then the point where A terminates, I start drawing B, then I draw B. And what is the initial point of A and the terminating point of B? If I join these two, then this is A plus B. Okay, this is A plus B. So this vector is basically A plus B, or I can write this is R, the resultant vector. Okay. I can also write, instead of A plus B, I can also write B plus A. Okay. So first I start with B. Okay. So let me start with B first. So this is B. This vector is B. So B, I start with B. The B ends here. Then from here I write A. So this is A. Again, final result is same. So this is A plus B. So whether I do A plus B or B plus A, the ultimately end result is same. Okay. So ultimately end result is same. So this is A plus B. This is A plus B. Or B plus A. This is B plus A. A plus B and B plus A are same. Okay. And sometimes in books we write it like the triangle law of vector addition. They will write the triangle law of vector addition. Now what is triangle law? Triangle law means we are writing a vector like this. So this is a vector A. Okay, and I have another vector, so this is another vector B. So what will be the resultant? This will be the resultant C, which is a resultant of A and B. Say it is R. So I will write that R equal to A plus B. This is vector addition, and this is the triangle law of vector addition, that if two vectors can be represented by two adjacent sides of a triangle taken in order, then the third side of the triangle in opposite order, will represent the resultant of these two vectors. So this is the resultant of these two vectors. This is the resultant of these two vectors. Okay, this is the resultant of these two vectors, right? Okay, so this is triangle law. And what I had drawn earlier, this was basically the parallelogram law of vector. This is the parallelogram. This is again, adding both the triangles. So whether you add A with B or whether you add B with A, it will be same. The resultant will be same. Okay. So this is parallelogram. That if two vectors A and B, if two vectors can be represented by the two adjacent sides of a parallelogram. These are two adjacent sides. If two vectors can be represented by two adjacent sides of a parallelogram, then the diagonal of the parallelogram passing through the intersection of these two adjacent sides, that diagonal will represent the resultant of these two vectors, right? These are the two vectors A and B, A and B, A and B, and this is the resultant. So if two vectors can be represented by the adjacent sides of a parallelogram, then the resultant of these two vectors will be the diagonal of the parallelogram passing through the point of intersection of these two vectors. Okay, this is parallelogram. So ultimately, there is one and same thing, the triangle law of vector addition or parallelogram law. Okay, so this is that. Now, how to find the resultant of any two given vectors? This is I have shown how we can understand, geographically, how to draw, geometrically, how can we draw vector, what will be the resultant. And of course, this is a very powerful, tool, very powerful technique. You can always solve any calculation on vector, geometrically. You can draw the vector, you can find the resultant and all those things. But the outcome, the answer would be a little bit approximation, because there is always, some error in drawing the vectors. So answer will not be 100% perfect. Answer may be 90, 95, 99% perfect, depending upon how accurately you are drawing it. But then how to calculate the 100% accurate answer? So we will have to go into, some analytical, mathematics. So let us do that. Okay. So we have two vectors. What is our objective? We are given two vectors and we have to find their resultant. Okay. Okay. So find resultant of two vectors. Resultant of two vectors. Okay. Please excuse me for my handwriting. Not good handwriting. Finding resultant, that means are doing vector addition. That is one and same thing. Okay. That is one and same thing. Vector addition. Okay. So now let's say we have two vectors. Okay. One vector is, let's say this is a vector. Okay. And let's say this is another vector. Right. This is one vector, blue one, and this is another vector, green one. Let us name this vector. Say this vector is P and say this vector is Q. Okay. So we know these two vectors are given to us, P and Q. The vectors are known to us, that means we know their magnitude and we also know their directions. Okay. And what is our objective? Our objective is to find the resultant vector, that is the resultant effect of these two vectors, mathematically. So let us draw these two vectors. Okay, so I take this I take this vector, I put it here. I can move any vector anywhere in the universe, as long as it is parallel and magnitude is same, the vector is same. And then I also move this vector from here to here. Okay, I put it like this. So what is the resultant vector? This is the resultant vector. Okay, this is the resultant vector. I have explained you just now. So let me write this as R. Okay, now let me just clear it little bit so that the figure looks nice and clear. So this is Q. Okay, and this is R. I can also copy. I can also start with Q. I can also start with Q from the same place and add P into that and add P into this. So ultimately, finally I will reach at the same place. Finally, I will reach at the same place. This is P. So let me delete this P from here. Okay. So these two vectors are known to me, P and Q, and my aim is to calculate R, what will be the resultant vector. And because these two vectors are known, that means their magnitude, this length is known to me. Say this length is P and say this length is Q. Okay, that means this length is Q and this length is P. Say the length of magnitude of vector P is P. And the direction is also known to me. That means let's say this angle between them is known to me, and let's say this angle is theta. Okay, so I need to find R. Okay, now you look at the geometry. Okay, using trigonometry we can easily calculate what is the value of R, isn't it? Right? Okay, I will calculate it. I will remove this Q from here so that my figure looks little bit you know cleaner. I will extend this side from here to here, and then I will draw a perpendicular from here on this side, right? Okay, so this is perpendicular. Now let me name it. Say this is A, say this is B, C, D, and E. Okay, now I have to, I have to calculate what is AD. This is my purpose. I want to find AD. This is P, this is Q, and this is theta. This length is P, this length is Q, and this angle is theta. So this angle would also be theta. This angle would also, because this is vector Q, this is vector Q, so both are parallel. So this angle is theta, this will also be theta. Now look at this triangle. Look at this triangle. In this triangle, okay, in this triangle, I will just draw this triangle, separately so that it is clear. This is D and C, and this is B, and this angle is theta, and this length is Q. Now what will be CD? CD over BD. CD over BD is equal to sine theta. The perpendicular divided by hypotenuse is sine theta. Our side, opposite side divided by hypotenuse is sine theta. Therefore, CD will be equal to BD sine theta. What is BD? BD is equal to Q. Therefore, CD will be equal to Q sine theta. Is it clear? CD will be Q sine theta. So this is Q sine theta. Okay. This is Q sine theta. Now let us calculate what is BC. Again, BC over BD. BC over BD. BC is the base. Base over hypotenuse is cos theta. Therefore, BC equal to BD cos theta. What is BD? BD is Q. Therefore, this will be Q cos theta. And therefore, this will be Q cos theta. This length is already we know, which is P, which is the magnitude of this. Okay, right? So now can we calculate R? Look at in this triangle, this complete triangle, this is a right angle triangle. We have to calculate AD. We know AC and CD. We already know AC and CD, and therefore we can say that AD square, the AD square would be AC square plus CD square. We have applied the Pythagoras theorem. Okay, that in a right angle triangle, the square of hypotenuse is equal to the sum of the squares of other two sides. Okay, we have to calculate AD. Therefore, AD square would be equal to AC. Now, AC is known to us. AC equal to AB plus BC. What is AC? AC is equal to AB plus BC. And what is AB? AB is P. What is BC? BC is Q cos theta. Okay, Q cos theta. So AC will be equal to P plus Q cos theta. So AC I can write P plus Q cos theta. Then AC is square, that means square of this, plus CD is square. What is CD? CD is Q sin theta. So this will be square of Q sin theta. Okay. Remember, P is known to us, Q is known to us, and theta is known to us. P, Q, and theta all known to us. That means AD is known to us. Magnitude of resultant is already known. Just simplify it. So apply P plus Q cos theta whole square. A plus B square equal to A square plus B square plus 2AB. Okay, so this square is already done, plus square of Q sin theta, which is Q square sin square theta. Okay, therefore AD square would be equal to P square plus, now look at these two terms. One is Q square cos square theta and one is Q square sin square theta. So let us take Q square, common from both of them. So this will be sin square theta plus cos square theta, plus the last term would be 2PQ cosine of theta. Okay. Now why we have done so? Because cos square theta plus sin square theta is always 1. That is why this is cos. That is why the name is cos. That is basically complementary sign. Cos square theta plus sin square theta is always 1, and therefore AD square, which is R square, the magnitude of R, will be equal to P square plus, because this is 1, so this will become Q square plus 2PQ cos theta. And therefore R would be equal to square root of P square plus Q square plus 2PQ cos theta. This is the formula to calculate the magnitude of the resultant of two vectors P and Q. These two vectors are known to us. Vector P is known to us and vector Q is known to us, and the angle between them, theta, is known to us. If these informations are available with us, we can very well calculate the magnitude of the resultant R. R is in this direction. This is the magnitude of R. R is square root of P square plus Q square plus 2PQ cos theta. Okay. So magnitude of the resultant is known to us, but it is still incomplete, because if you want to find a vector, you have to find its magnitude and direction both. So we have to find the direction of R. Direction of R means we need to find this angle. Okay, let this angle is alpha. Again from the same triangle ADC. Look at this triangle ADC. Look at this triangle ADC. DC over AC will be the tangent of alpha. DC over AC will be the tangent of alpha, and therefore tan alpha would be DC. What is DC? DC is equal to Q sine alpha theta divided by AC. What is AC? AC is equal to P plus Q cos theta. Cos theta. Okay. So from here we can calculate what will be alpha. Okay. We know tan alpha because we know what is P and Q is known to us and theta is also known to us. Therefore, we can measure their ratio. That means we know what is tan alpha and therefore we know what is alpha. Okay. So in this way, we can, calculate the resultant vector of two vectors or the addition of two vectors. Okay. Finding resultant vector and doing addition is one and same thing. Okay. Right. If both the vectors are in same direction, that means theta would be 0. Both are in same direction, theta would be 0, and cos 0 is 1. Therefore R will be p square plus q square plus 2pq, because cos theta is 1. That means p plus q whole square. That means R will be p plus q. We'll add 3 plus 5 equal to 8. If these two vectors are perpendicular to each other, that means theta is 90°, and if it is cos 90 is 0, therefore this term vanishes. Therefore R square will be p square plus q square, right angle triangle. Right? So depending upon the angle, the value, the magnitude of direction will go on changing, as well as the direction of R will also change. The magnitude and direction will also change because direction also depends upon the angle. Okay. Let us take one example. Okay, let's take one example. We have a vector along east. Say this is a 5 meter per second, and we have a vector making an angle of 30° from the north. Say this is north. Say this is east, this is north, this is west, and this is south. This is another vector. Say this is 7 meter per second, and say this is 30° west of north. This is 30° west of north. Okay, and we have to add these two vectors. If we have to add these two vectors, that means we have to find their resultant of these two vectors. Okay, one vector is 5 meter per second towards the east, another vector is 7 meter per second, making an angle of 30° west of north. Okay, so these are the two vectors. Find the resultant. So what is the angle between two vectors? What is this angle? This angle is 90 plus 30, that means 120°. So we know P is equal to 5, we know Q is equal to 7, we know theta is equal to 120, and therefore R would be square root of P square, which is 5 square, plus Q square, which is 7 square, plus 2 times P into Q into cosine of 120. And if we simplify it, you will find that this is 25 plus 7 square is 49 plus 70 times what is the value of cos 120. Let me just use my calculator to find the value of cos 120. Okay, just a second. So cos of 120 is equal to minus half. So this is minus half. Okay, so this would be square root of 25 plus 49 and then minus of 35. So this is 6.24. This would be the resultant. Okay, what would be the angle? Angle we know tan alpha is equal to Q sine theta over P plus Q cos theta. What is P? P is 5. Sine 120 divided by P is 5 plus Q 7 cos 120. Okay. Now what is sine 120? Sine 120 is 0.866. So 5 into 0.866 divided by 5 plus cos 120. Cos 120 is 0.5 multiplied by 7 is this. So minus 3.5. So this is minus 3.5. So now this will be how much? 5 multiplied by 0.8666 is this much, divided by 1.5 is this 2.88. 2.88. This is 10 alpha, and therefore alpha will be 10 inverse of this. So 10 inverse of 2.88. So this is 70.8 degree. 70.85 degree. This is the angle. And this angle we had measured from here. So this is 70.8. So somewhere here will be the resultant. This would be the resultant. You can see if you draw, a parallelogram like this, this will be the resultant. Its length will be 6.24 and angle will be 70.85. Okay. So this is one method of calculating the resultant of two vectors. You just need to know two vectors p and q. You know the two vectors, that means you know their magnitude and the directions. So if there is a vector p and if there is another vector q, and if the angle between the two vectors is theta, then the resultant magnitude of the resultant will be square root of p square plus q square plus 2pq cos theta, and the angle which this resultant would be making with the first vector p alpha, that angle will be given by tan alpha will be q sin alpha divided by p plus q cos alpha. Okay, so you know the direction, magnitude and direction of the resultant of both the vectors. So this is one technique of how you can calculate the resultant of two vectors. Okay, in my next video I will try to I will give another method of finding the resultant of two vectors or more than two vectors. I mean whatever number of vectors we have. Okay, so I hope uh, uh, everything is clear to you, and in case if you have any doubt you can please write in the comments. Okay, so I will try to clarify the doubts. Okay, so now I discontinue here. Okay.